It might seem obvious because you're just looking and you're counting the number of HCl and you're thinking, why are we doing this? Well, in a titration, the point is that it's blind. You don't know the concentration. You don't know how many HCls are in the water. So what we do is we put a little bit of a drop of indicator in here. And indicators are all different. The one that most people are most comfortable with is usually litmus paper, which is an indicator that's been embedded on a thin strip of paper. But there are plenty of other indicators, and some indicators are colorless when they're in an acid environment, and they are pink in a base environment. Now, there are more details to this. Just know that in the lab that you guys will be doing, this is the situation. We put the little indicator drops in, and you notice it's still that watercolor. It's definitely not pink. So that tells us that there are HCls in there. So we drop in our NaOH. From that drop, you know, there were 2 of them. And it still is colorless. You're thinking, okay, so what do I do? Well, you let the next drop go in. So the next drop puts some more of these guys in. And at this point, what happens is suddenly the solution turns pink. So what does that mean when it turns pink? It means that you have excess base. It means that you've run out of HCl to work with. You don't have any. So does it make sense that we have extra base? Let's see. This reaction took care of one of these HCl's. This reaction took one of the HCl's, and this reaction took one of the HCl's. There was extra NaOH. So that means that we've put in just past the amount of NaOH that is needed for the amount of the flask. This is how a titration works. That color change, that barely there color change, is the moment when your solution flips from having the extra HCl to having extra NaOH. And then that's what you record off of your measurement. You record that volume that you put in.